Hello guys, you're welcome to uComputing's YouTube channel. My name is Eugene, and in this video, we're going to have a look at how we can partition and mount disks on a Linux operating system. Now, this demo that we're going to do, you can try it with any Linux distribution, whether you're using Ubuntu, Red Hat, SUSE, or whatever. It doesn't really matter. Okay, the tool we're going to use to do this particular demo is in all the Linux distributions. Now, before we begin, there are a few things that you need to understand about partitioning and mounting disks on a Linux operating system. The reason why I'm using the term mounting is that on a Linux operating system, when you create a partition, you don't give it a drive letter like how we have in Windows. You mount it in a folder or a directory. So if you look at this diagram that I've done over here, first section of the diagram has to do with how we normally partition disks in a Windows operating system. Normally, you create the partitions from physical disks and then you give them drive letters like drive D, drive C. But in a Linux operating system, we don't have drive letters. So when you create a partition, you have to mount it in a folder. Before we proceed, there is also something else that you need to understand. If you look at this chart that I've created over here, it's a numerical permission chart. Now, in the Linux operating system, we use numbers to assign permissions. The reason why I brought this up before we begin the demo is that when you create a folder that you're going to mount your partition to, you need to assign a permission to it before your users can access it. Okay, let's have a look at the demo. So I have here with me an OpenSUSE Linux distribution. I'm going to log in here as a limited user. Once you get into the operating system, the first thing that you need to look for is the terminal, right? Almost every Linux distribution has a terminal, and that's what we use to do most of the actual tasks. As you have noticed, I'm not using the term operating system because when you go to the Linux world, they use a term distribution for operating system. I'm going to begin by clicking on the application menu over here in my OpenSUSE Linux distribution, and I'm going to look for my terminal. Okay, on the system we have terminal. If you come to the application menu and you don't find the terminal, you can just use a search over here by typing term over here and then launch it. Once you get into the Linux terminal, you can adjust the view by pressing Ctrl key plus Shift and plus. Now, once you get into the terminal, the first thing that you need to do is to check who is currently logged on. To see who is currently logged on, I'm going to use the command who am I. When I type who am I over here, it tells me that the user that's currently logged on is Giku, but the task that we are about to perform is an administrative task, or in the Linux world, they will say super user task or root task, right? So we need to log into the terminal as root or super user before we can proceed. So to do that, you use the command su and press enter to switch user from the limited user to super user, aka root. I'm going to type my root password, and as you have noticed, whilst I'm typing the password, it's not showing any dots, right? This is a security mechanism that has been placed in the Linux terminal that prevents someone that is probably looking over your shoulder from seeing even the length of your password. Okay, so I'm going to press enter here to gain root access to the terminal. When you get into the Linux terminal, what is going to help you determine whether or not you've logged in as root or super user, aka administrator, is this hash sign over here. When you log into a Linux terminal and you see this tilde sign or a dollar sign, it means you're currently logged in as a limited user. But once you see the hash, it means you have higher privilege. You're going to check the partitions or the disks that we already have on this Linux system by typing the command df space -h. When I type df space -h, it tells me that we have a couple of drives over here, but we're going to concentrate on this very one over here. Additionally, you can see that there's another partition over here, which is 2 GB, right? And this 2 GB partition has been mounted on a folder called share. So we're also going to have a look at how we can create a new partition and then mount them. So there is a tool in the Linux operating system called Fdisk. That is what we use to partition disks and manage disks in the Linux operating system. So how do we even determine the physical disks in the system? We have a directory on the Linux operating system or a folder on the Linux operating system called dev. Within the dev directory is where we have all the devices mounted. So let's get into that particular directory and see what is in there. I'm going to type cd. The command cd is used to change directory or folders in the Linux terminal. I'm going to type cd, then I'll bring the root, which is the beginning of the operating system, and then I'll bring the dev directory. The dev directory is inside root. So I'll type cd /dev and press enter here. Now, when I type ls over here, ls is used to list the content of a folder or a directory in the Linux operating system. So when I type ls over here and I press enter, it tells me there's a whole bunch of stuff in here. But what we are interested in is this one over here. Now, the Linux operating system, anytime you plug an IDE drive or a SATA hard drive or a SCSI drive, if it's an IDE drive, you label it with HD. So when you see HDA in the dev directory, it means IDE drive 1. But IDE drives are obsolete, so I'm going to focus on SATA and SCSI drives. Now, for SATA and SCSI drives, the Linux operating systems label them as SD. So as you can see, we have SDA over here, we have SDB over here, no SDC. So the SDA over here and the SDB over here tells us that we have two physical SATA disks or SCSI disks on this Linux system. Now, you can also see that we have SDA1 over here. What does that mean? And SDA2. You also have SDB2 over here and then SDB1. Now, SDA stands for first physical SATA or SCSI disk. SDA1 stands for first partition on first SATA or SCSI disk on the system. So this would automatically mean second partition on the first SATA or SCSI disk on this system. When you go to SDB, it means second SATA or SCSI disk on the system. SDB1 obviously will mean first partition on the second SATA or SCSI disk on the system. So this information over here in the dev directory regarding these SDAs and SDBs tells us that we have two physical disks on this system. And on each of these disks, we have two partitions each. All right. Now, the SDA is what is hosting the operating system for this particular Linux distribution right now. So we're not going to touch it, but we're going to work with the SDB. So we're going to select the SDB and start working on it. We're going to create more partitions on this SDB disk over here, which is the second SATA hard drive on this machine. Okay. So let's begin by running the fdisk command. I'm going to type fdisk. And take note that before you can use the fdisk command, you have to make sure you've logged into the Linux terminal as super user. As you can see, I've logged in here as root, so we have the hash sign. So I'm going to type fdisk, then I'll bring the device ID over here, which is SDB. We're going to work on SDB. And SDB, don't forget, is in, I'm going to scroll up, the dev directory. So I'll not just type fdisk SDB. I'm going to type fdisk root dev /SDB. This means that I want to select SDB or the second SATA hard drive and work on it. So I'm going to press enter here to select the second SATA hard drive. Now, to create new partitions on this, as you can see, they have given us a parameter over here, M, for help. So in case you forget the fdisk commands, you can just press M, go enter here, and it gives you a list of parameters that you can use over here and explain to you what they are for. As you can see, the N command over here is used to add a new partition. So you're about to add a new partition to our SDB drive. And this one over here is just used to view the partition table. Okay, we're going to use these two commands over here, N and P. So let's begin. I'm going to press N over here to create or add a new partition and press enter. It asks me whether I want to create a logical partition or a primary partition, right? I'm going to go for primary partition by pressing P over here and press enter. It asks me to specify the partition number, and it has already indicated over here that the default is 3. So I can press enter to pick the default, or I can just type 3 and press enter, right? And when you're creating a partition in a Linux operating system, it asks you of the beginning cylinder and the end cylinder, aka the first sector and then the last sector. There's not anything complicated to worry about. Okay, the default is already here. So even if you don't understand, you can just press enter here and it picks the default first sector. But the most important thing is the end cylinder or the last sector. That is where you're going to specify the size of the partition you want to create. So you need to bring a plus sign first. So you bring a plus sign, and then I'm going to specify the size of my disk. Okay, let's say I want to create 4 GB storage. I'm going to type 4 GB over here, and then I can go ahead and press enter. Don't forget that there are other parameters over here that you can use. You can type plus 4 GB, you can type plus 4G. The parameter over here also works. It's very flexible. K is for kilobyte, M is for megabyte, terabyte, petabyte. All right. So I'm going to press enter here to create a 4 GB partition of this SDB disk. So I'm going to press enter here. It creates a partition for me, partition of 4 GB. Now, to see whether or not the partition has been created, we need to print the partition table or view the partition table to see if it's actually there. So I'm going to press from the information that we saw here from the help. It tells us if you want to view the partition table, you press P. So I'm going to go here and press P and go enter. And it tells me I have a 4 GB disk. This one over here in particular, 4 GB. It's 3.7 GB, but it's approximately 4 GB. You already have an SDB1, SDB2. So the recent one that we created is listed below over here, SDB3. As you saw earlier on from the dev directory, we have SDB1, SDB2 already. So once we write the changes, we should have an SDB3 over there. Whatever that we've done over here has not been written to the partition table yet. If I close this terminal right now, the changes that I've done to this particular disk will not take effect. So to write the current changes that we've done to the partition table, we have to press the letter W. When you look at the help that was given here earlier on, it tells you W write table to disk and exit. Okay, so W is going to just save our changes and exit from the Fdisk. Command line 2. I'm going to press enter here. Okay, so the reason why we are getting this error is that we need to perform a reboot before I can see the changes on the partition table. Or what I can do is that I can just run patprobe. There's a command called patprobe that you can use to update the kernel's partition table. So I'm going to run patprobe over here and go for enter. Okay, so after this command, what I'm going to do is that I'm going to just create a file system on this SDB3 that I've just created. It is very important. So after you run patprobe to update the kernel's partition table, the next thing that you need to do is to create a file system for the partition that you've created. So I'm going to run this command over here, mkfs, then I'll bring the parameter -t, then I'll specify the file system I want to create for this my SDB3. The file system I want to use is extension 4 file system, so I'll type ext4 and leave a space. Then you can bring other parameters for more details, but this is just okay. The next thing I'm going to do is that I'm going to specify the path to where my partition has been mounted. My partition has been mounted in dev as SDB3. So I'll say /dev SDB3. This is going to create extension 4 file system for the third partition I have created on my second SATA hard drive. I'm going to press enter here. It creates the file system for me. Everything looks good. Now, the next thing I'm going to do is that I'm going to have a look at where I can mount this particular extension 4 file system partition that I have created. As I said earlier on a Linux operating system, we don't associate partitions with drive letters. We mount partitions in folders, right? So what I'm going to do is that I'm going to go to the root of this particular Linux operating system and create a folder, a simple folder. So I'm going to go cd space /. The / is the root of the operating system, aka drive C. I'll press enter here to take me to the root of the operating system. And then I'll create a folder, aka directory. Okay. By using the command md, then I'll bring the folder name that I want. I'm going to call my folder music volume, okay, and then go for enter. Once the folder or the directory is created, I'm going to type ls over here to see if it actually exists. I'm going to list the directory content of the root, and it tells me I have a folder over here called music volume. In order to mount this partition that I've just created and given it extension 4 file system to this folder, this is what I need to do. There is a configuration file called fstab. The fstab configuration file controls or stores information for all the partitions that we have on a Linux operating system. So we need to edit the fstab configuration file and manually input information that will tell the kernel of the operating system that there is a new partition that has been mounted to this particular folder that we have just created. Okay, so I'm going to get into this fstab configuration file and make modifications to instruct the operating system that we have a new partition and it's supposed to be mounted on music volume, which is the folder that we just created. So I'm going to go ahead and access the fstab configuration file. As I said earlier on, fstab configuration file is in the etc directory. There's a folder on the root of a Linux operating system called etc. Right now, we are on the root of the Linux operating system. So when I run ls over here to see the contents of this directory, I've already done that. It tells me there's a folder over here called etc. It is within this etc directory that we have that configuration file that stores information for partitions. Okay, so I'm going to type cd over here to get into this particular directory. Type cd etc, enter, and I'll run ls to see whether the fstab configuration file I'm about to edit is actually in this folder. So when I run ls, it gives me a long list of stuff here. But what I'm looking for here is this guy, fstab, right? So the fstab configuration file is in the etc directory, right? So we need to edit this and instruct it to accept our new partition. So to do that, I'm going to use a text editor called VI. Now, VI has been in the Linux operating system for a very long time and is in all the Linux distributions. So that is the reason why I'm going to use this to do the demo. There are other text editors that you can use to do this. If you want to use Emacs or any other text editor like gedit, it's fine. But in this video, I'm going to use the VI text editor. So to edit the fstab configuration file, which is in the etc directory, I'm going to type vi space the name of the configuration file. So the name of the configuration file is fstab. I will type vi fstab. I'll press the tab key to complete for me and then press enter here to open the configuration file. Now, when you look at this configuration file, you can see there are some partitions already in here. There are 3 partitions in here. And our partition that we just created, which is supposed to be mounted on the music volume folder on root, is not here. So we have to make sure we bring it over here. But the problem is that we know the directory to where we want to mount our new partition. We know the file system and other parameters, but this guy over here, how do we get this? Okay, so let me show you a trick. I'm going to press escape over here and press shift:_Q. The letter Q is the command that we use to leave the VI text editor if you haven't used it before. This is what you need to do. You press escape, press and hold shift, bring colon, and type Q, small q. Linux is case sensitive. If you type the small q and it's still giving you error, you can add exclamation like this. This means force quit. So shift-1 will bring the exclamation and it will force a quit. I'm going to press enter here to leave this configuration file. Of course, we have to go and look for the UUID for the partition we just created. Now, I'm going to press enter here to leave the fstab configuration file. Now, how do you get this UUID for the new partition you've created? I'm going to scroll up a little bit for us to see the previous commands here. You see that when we created an extension for file system on our SDB3, it generated a UUID. This is the UUID we need in that configuration file. So if you miss this, it's no problem. There is a command you can still use to trigger the UUID for any partition on your system to appear. Now, let me give you that command over here. Block ID. When you type block ID and you press, not block ID in full, BLK ID. Okay. Now, when you execute this command over here, as you can see, it gives us a whole bunch of things here. But look here, SDB3. The UUID for SDB3 is right here. So you can copy it from here and then send it to your fstab configuration file. So I'm going to just highlight it by clicking and holding here to highlight. And then I'm going to right click and copy. This is what we need. And then Linux keeps a history of commands that you've already typed in the Linux terminal. So I'm not going to type it again. I'm going to press the up arrow to bring the previous commands. And as you can see, very soon we find our VI fstab. Okay, so I'm going to get into the fstab again with the VI fstab by pressing enter. And then when you get into the VI text editor, we have 2 modes, the command mode and the insert mode. The initial mode for the VI text editor is command mode. Okay, that one you cannot really make any changes. So if you want to make changes to any file that you're opening with VI for the first time, you need to press either the insert key on your keyboard or letter I, and it changes the mode of the VI text editor to insert. Now you can input new information. So this is what I'm going to do. Over here, the mouse doesn't work, so I'm going to use the arrow key to the right to move to the end of this third line. I press enter, and I'm going to just right click and paste my UUID for my new partition. Right now, the inverted commas has to be removed, so I'm going to clean this up. Use the left arrow, bring the left arrow to the side, and press backspace. Right, so I need to remove these inverted commas, and then I'll leave a space and specify the path to where I want to mount this particular partition, which is SDB3's UUID. Right, the UUID here is for SDB3, the partition that we just created. So in order to mount it on the music volume, which is on root, I'll bring the / which is root, and type music volume. You have to be very accurate with your syntaxes. Okay, so music volume has to be music volume, just like how you typed it. Okay, if it was small m, you have to use small m over here. You don't need to change it to capital M. Linux is very case sensitive. So I'm going to leave a space here and then put the file system for this particular partition, which is about to be mounted on this music volume over here. The file system that we used, you remember, is extension 4 file system. So I'll type ext4 here, and then I'll leave a space. You can also use the tab key, it's fine. Then I'll type here default with an S. I'll leave a space and type 1 space 1. Okay. Now, the alteration we need to do to our FSTab configuration file is complete. The next thing that we need to do is that we need to save our changes. To save changes in the VI text editor, you need to press the escape key, press and hold the shift key, press colon, and type WQ. Right. Now, when you do all these things and you press enter and you are still getting an error, I've told you in order to force and execute this particular command, you can bring an exclamation. Okay, but this one is not needed. I'm going to press enter here, and it saves the changes to my FSTab configuration file. How do I know it's saved? There's a command called cat that you can use to view the information within a file. Okay, so I'm going to view the content of the FSTab configuration file if what I see is actually well saved by typing cat FSTab. Press enter here. It tells me my information is well received. So there's a command you can use to finish all these configurations that we have done. The final command that you need to run is mount space -a. This will remount all the partitions that we have on this Linux system. Now, when I press enter over here, we don't get any errors over here, so it shows that everything is successful. How do we know it's successful? Now, let's go and check. I'm going to minimize this terminal over here and get into Linux File Explorer. As you can see, when you get into this Dolphin application, that is the name that is given to Linux File Explorers, you can see that the 4 GB drive is up and running here. It's been mounted successfully. So we can go ahead and put information in here. Now, don't forget that we created a folder on the root of this particular system called music volume. So this partition over here has actually been mounted on this music volume. So anything that we put into this music volume on the root of our operating system will automatically come here. As you can see, when I go to the root of this particular system and click this folder, it takes me back to the 4 GB drive, right? So everything looks perfect. Now, let's try and populate it with files and see whether or not it's going to work. Okay, so I'm going to go into my documents folder in my home directory. I think I have a file over here. Document, there's a file over here. I'm going to just copy it and try and paste it into this particular partition, right? I'm going to go through the root of the system, open the music volume folder. It takes me back here. And then when I try to paste, look what's happening here. It's not working. This has to do with permission problems, right? So we have to set the right permission for this music volume folder over here in order for us to populate it with files successfully. Okay, so I'm going to take you back a little bit. As you can see from the previous slide that I gave you, we have some numerical permissions in Linux. In order to give full control to users on the system, we need to use this numeric permissions over here. So we're going to have a look at how we can do that. Back on my Linux system, the last phase of this particular demo will have to be changing the permission of this folder in order for it to be read-write so that we can keep files in it. I'm going to go back to my terminal, and then we're going to look for this particular directory. I'm going to do cd and go back to root. When I do ls on root, you can tell, as you can see, we have our music volume over here. So what I'm going to do is that I'm going to use a command called chmod. That is a command we use to modify permissions for directories in Linux. I use it to modify the permission on this very volume over here. I'm going to give it the highest permission, which is not really recommended. You can use the read write, which is 666. I'm going to give it full control by typing chmod 777 full control for everybody. I know it's dangerous. Security guys, please forgive me. Okay, now chmod 777 space the directory, which is music volume. Then I'll press enter here. It changes the permission for the directory. Now let's go check. When we try to copy something from our document folder into the music volume folder, which is this our drive over here, it's working now. So when you finish doing this and the directory or the partition is not allowing you to store files in it, this is just the problem. You just need to change the permission for the folder on which the partition has been mounted, and everything will be fine. When I paste, as you can see, it's working nicely. So anytime you place a file in here, it goes into the new partition that we just created. Okay, I'm going to end it here. Thank you very much for watching. If you like this video, kindly subscribe to support our channel. Thank you.